So in the first problem, we're starting off with a perimeter scale factor of 16. So going back to the original problems, the linear scale factor and the perimeter scale factor we discussed on Tuesday were the same number. So if this perimeter is 16, that means the linear scale factor is also 16. The area scale factor would be 16 times 16, or 256. So hopefully you selected 256 as your answer to question 1. In the second question, the area scale factor is 16, and they're asking for the perimeter scale factor. So to get the area scale factor of 16, that means the number we would be multiplying to itself would be 4. So the linear scale factor and the perimeter scale factor in both problems, or both cases, is 4. So in this problem, the perimeter of the triangle on the right is 26, and the area is 32.24. The linear scale factor between the two triangles is 6. The perimeter scale factor would also be 6. And then the area scale factor will be 36. We're doing 6 times 6. So to find the perimeter of the image, we can simply multiply the original perimeter by 6. So 26 times 6 is 156. That would be the perimeter of the image. And for the area, we would multiply the 32.24 by 36. And so the area would be 1,160.64 square units. So we have two approaches. Maybe you took the time to find the measurements of the lengths of the missing sides and the height of that triangle on the left, and that's perfectly okay as well using the scale factor of 6. But we, based on the first set of problems that you did from Tuesday, we could also use the patterns that we came up with for scale factor and use those numbers as a way of also determining the area and perimeter of the image. So the original trapezoid, which on the right, the perimeter is 39.5, and the area is 84 square units. Going from the original to the new shape, that scale factor is 3. And again, that's the linear scale factor. So the linear scale factor is 3. The perimeter scale factor is also 3. And then the area scale factor is 3 times 3, or 9. So if I want to find the perimeter of the image, we'll take 39.5 and multiply it by 3. So that would be 118.5. And to find the area, we would multiply 84 by 9, since that's the scale factor. So the area would be 756 square units. So in this problem, the perimeter of the shape on the left would be 14, and the area would be 12 square units. The scale factor between the two shapes is 2. So the original is 14 and 12, and the image is going to be twice as much, or 4 times as much. Now in this problem here, it was set up a little differently. So the scale factor is going to not be the image over the original, but the original over the image. So I'm not sure if you caught that or not. But so to get to the image, we're going to multiply by 2, which is 28. To get to the area of the image, we multiply by 4, which is 48. But for the linear scale factor, they want the original over the image. So that would be 14 over 28 for the scale factor linear as well as the perimeter. So that would simplify to half in both cases. And then the area would be 12 over 48, which simplifies to 1/4, which is also 1/2 times 1/2. So we take the linear scale factor and multiply it to itself or square it to get to the area. So if you put in 2, 2, and 4 instead of half, 1/2, and 1/4, you probably got an error on this problem. So problem number 1 is asking for the linear scale factor. So between the two shapes, we're looking at 10 and 40. So the scale factor would be 4. It could also be 1/4. So this depends on in which way they want the ratio entered in. So if 4 doesn't work, then it would be 10 over 40 or 1/4. Second question asks you to determine the area of the smaller shape. So if the linear scale factor is 4, then that means the area scale factor is going to be 4 times 4 or 16. So if the bigger area is 656, then the smaller area would be 41. So 656 divided by the scale factor 16 gives me the area of 41. So in this problem, it's asking you, do you agree with the salesperson's comment about the fact the cost would be $400? So in a room that's 16 by 24, if that's the original room for $800 and there's a mistake and the room really is 8 by 12, that means the room itself is going to be that much of the original. So it's not going to actually be half of the cost because this area here is not half of the original room. It actually is 1/4. So the cost of this carpeting should be $200 or 1/4 of the $800. So in this problem, the linear scale factor is 3. Take the bigger number divided by the smaller. So that means for the area scale factor, it should be 3 times 3 or 9. And if you take 360 divided by 40, you get 9. So it appears that, at least in terms of these two pieces of information, that the scale factors match up in terms of the pattern discussed in the first 3 activities in this decimal sketch or problem. But here is the answer to the question: are the shapes similar? And so the question is: are there other shapes that could have a height of 21 and have an area of 360 square units or square feet, and not be the shape pictured here? In other words, is it possible to have other shapes with the information on the bottom, but not be that shape? So, for example, is it possible that the shape could be a rectangle? If my height is 21 and the area is 360, can we determine what that base would be so that the shape itself would actually fit the criteria? The height's 21, the area is 360, but the shape itself is no longer a pentagon, but actually now it's a quadrilateral. So it decided if there's enough information to determine if the shapes are similar. So based on the perimeter and area, it appears to be yes, but what we don't know is the fact that the shapes themselves, there's no guarantee that the shapes are the same shape in terms of a scale copy of the other. So that's the issue in this problem here, that there are other shapes that could have the 21 and 360 and not be a pentagon. So at the completion of this activity and based on your work and the conversation that I'm providing through this video, what is your confidence level on this activity? How well do you feel how confident you feel in being able to find area and perimeter answers for shapes that are actually similar or scale copies of each other. How well do you understand the patterns in terms of the scale factor pattern for linear perimeter and area? So go ahead, if you have not, make sure you indicate your confidence level. If there's anything that you want to add in terms of additional information that you would like to share, please do so.